Hey guys, today we are starting out our Unit 5, and we're going to be starting by solving quadratic equations by factoring. So first of all, it's important to understand why do we worry, what is the importance of factoring, and why are we doing it. So the solutions to a quadratic equation, when you solve a quadratic equation, you're finding the x-intercepts of your parabola. These sometimes can be called zeros or roots. So if you see any of those words, solutions, roots, zeros, they're all talking about the same thing, and they're referring to these x-intercepts. So if we were looking at this graph and we solved it, we would say that the solutions were -2 and 3, which were our x-intercepts in our function, in our graph, in the parabola. So a couple things that you need to think about whenever you're solving a quadratic equation is that the first step we need to do is to make sure that everything is on one side of the equation equal to 0. So we look in our example over here, we have this -6 on the right-hand side. So we're going to add 6 to both sides to move that over so that then my quadratic equation is equal to 0. And then we're going to factor using our factoring methods. So we would know we'd draw our little x, we'd be looking for numbers that multiply to 6, that combine to 5. We notice that the signs are the same and they're both positive. So that would be our +3 and +2. So that's where we got our two factors. So we factored the x squared plus 5x plus 6 into x plus 3 times x plus 2 is equal to 0. Now, there's such a thing called the zero product property, and what the zero product property says that if two things are multiplied equal to 0, that one or both of those factors must be equal to 0. So using the zero product property, we're able to set each one of our parentheses, x plus 3 equals 0 and x plus 2 is equal to 0. So when we solve those equations, we get that x is equal to -3 and x is equal to -2. So those would be our solutions or our roots for our quadratic equation. So now let's look at a couple of examples. So we've got our first equation. We notice that everything is on one side equal to 0. So now we're ready to factor. We're looking for two numbers that multiply to give me 9, that add to give me 6. We know that those are +3 and +3. So we go over here and factor x plus 3 times x plus 3 is equal to 0. Now, remember, we always want to check our factoring. So we're going to just really quickly in our head, x times x is x squared. My outer is 3x, my inner is 3x. So 3x plus 3x is 6x. And 3 times 3 is 9. So we know we factored it right. So now we would be setting each one of these equations equal to 0. So x is equal to -3, and we see x is equal to -3. And so when we have a root that is the solution twice, we refer to this as a double root. So we would write it as x is equal to -3, and then we would put the dr behind it. And remember that dr stands for double root. Okay, that just means that it is a solution 2 times. And we'll talk a little bit more about what we know about double roots in a little bit. Okay, so our next one, we look and we see that everything is equal to 0, so that's where we want it to be. And so we start to factor this quadratic. Well, we notice it's a cubic, so we look and we say, okay, is there a GCF that can come out? We do see one. We see that it is x, and then I'm left with x squared minus 9 is equal to 0. So I recognize I have two terms. It's a perfect square minus a perfect square. So this is our difference of squares. So we bring our GCF down, that x, and then we write ourselves two sets of parentheses, a plus in one and a minus in the other, and we know that we're still equal to 0. So we take our kind of pattern for difference of squares. We take our x squared, the square root of that would be x, and the square root of 9 is 3 and 3. Okay, So notice up in our very first expression, we had x to the third, and whatever the degree of our variable is how many solutions we should expect to have. So we know that we would set these two parentheses equal to 0 like we did in our last example, but because our GCF also has a variable, we would need to set the GCF equal to 0 as well. So we have x is equal to 0, x plus 3 is equal to 0, and x minus 3 is equal to 0. Well, there's nothing needed to solve there, but then we would see x is equal to negative 3 and x is equal to positive 3. So we could write our solutions in the set 0, negative 3, 3. All right, our next example, we again notice that there's an x cubed, and the only way we know how to do an x cubed is if it's a sum or difference of cubes, so we have to assume that this is a GCF. Well, I notice that x cubed, x squared, and x, every term has an x, so we can factor out that x again, and then I'm left with x squared plus 3x minus 4 is equal to 0. So now we follow our pattern for factoring trinomials. We're looking for numbers that multiply to give me negative 4 and combine to give me positive 3. Now remember, when that constant is negative, it means our signs are going to be opposite. So I notice that a plus 4 and a minus 1 would multiply to give me my negative 4 and combine to give me my positive 3. So I'm going to bring my GCF, just keep bringing that x down, split my my trinomial into two binomials. The only way we get x squared is x times x, and then we know that we had a plus 4 and a minus 1. Okay, now at this step, I'm going to show one more time that you're setting each one of these parentheses equal to 0. But what we notice whenever we do that is that our root is just the opposite of the term that's in there. So if you want to skip this step of showing each one, solving each little small expression equal to 0, you can go ahead and just jump into, that it's the opposite. But again, if you need to show the step, then go ahead and do so. Sorry, I'll put that 0 in the middle. There we go. And there's our set of solutions. And again, we notice that we had an x cubed, so we should expect to have 3 solutions. All right, looking at our next one, we see that we're not set equal to 0, so the first thing I need to do is move this 36 over. So I'm going to add it to both sides, x to the 4th minus 13x squared plus 36 is equal to 0. So we have a trinomial. We're going to follow that trinomial pattern. There's no coefficient here, so I'm just looking for numbers that multiply to 36 and combine to negative 13. So again, the numbers would be the same, and they're both going to be negative. And I noticed that negative 9 and negative 4 would work. So we split into our binomials. Now, I do notice that this time our variable was our exponent was x to the 4th. And so we know that the way we would get x to the 4th is to multiply x squared times x squared. And then I can bring in my minus 9 and my minus 4. Now, wait a minute. Are these done factoring? No, I notice a difference of squares over here, something squared minus something squared, and something squared minus something squared over here. So I need to follow that pattern and factor these into differences of squares. So there's my two parentheses with a plus and a minus for my x squared minus 9. I know the only way to get x squared, we would multiply x times x. The square root of 9 is 3 and 3. Then we're going to do the same pattern for our x squared plus 4 minus 4. We have our plus and our minus. Square root of x squared is x and x. The square root of 4 is 2 and 2, and we're still equal to 0. So again, we would know that we could set all of these parentheses equal to 0 in order to solve, but we can also kind of skip that step and say, okay, I know that they're always the opposite sign, so that plus 3 would be a minus 3. This minus 3 would become a positive 3. My plus 2, I would subtract it. It would become negative 2. And my last minus 2 would become a positive 2. And so we can write that, either leave it as our x equals, or we can write it in our set. So we would have negative 3, negative 2, 2, and 3. Oops, 3. And then we close that bracket. So again, we saw that our beginning exponent was 4, and so we notice that we have 4 solutions. Now let's look at a couple more examples. So we notice again that not all of our numbers are on one side with our quadratic equals 0. So we're going to subtract that 29 to bring it over. And remember, I want to put it in standard form, so I'm going to move that x term to the middle. So minus 29x plus 5 is equal to 0, because we want it in standard form in order for us to factor. So now, remember, when I have a coefficient in front of my squared term, I'm going to take that and multiply it by the constant. So I'm looking for two numbers that multiply to give me 100 and combine to give me negative 29. Now, I know those numbers are negative 25 and negative 4, so I would just bring that down over here, and I would say, okay, x minus 25 times x minus 4. But then we remember, because x times x does not give me 20x, so remember that our last step is that we're going to take each one of these terms that we found, and we're going to divide them by 20. So again, we're still equal to 0, so I'm going to show that step. So x minus 25 over 20 would reduce to 5/4, and 4 over 20 would reduce to, oops, sorry, that's a minus 1/5. Okay, now we know if we were factoring and all we were doing was trying to just factor this quadratic, we know that we would swing this 4 and this 5 up to be coefficients, so that way we would multiply back together and get our original trinomial if we were trying to just check our answer. Well, when we're solving, we don't want to go ahead and move that back up because we're trying to get x alone, right? And so if our solutions, we would see, are just going to be fractions instead of having our factors, be 4x minus 5. We really only care about solutions, so we don't need to take that last step and swing that 4 or swing that 5. We can see that it would be 5 over 4 or 1/4. And so these would be our solutions. All right, now sometimes you're going to have to do a little bit more work in order to get things equal to 0. So I see that I need to distribute my 5. So I have 24x is equal to 5x squared minus 5. Now I notice I still need to get everything over to one side. Now I'm going to leave the 5x squared over here because it's positive, and I'd always rather factor something with a positive coefficient. So I'm going to move the 24x over to this side, and again, put it in the middle of those two terms so I can have this in standard form. So 5x squared minus 24x minus 5. So again, I'm going to look and I say, all right, what multiplies? I take the 5 times the negative 5, multiplies to negative 25, combines to negative 24. Now I notice that because this is minus, that my signs are going to be opposite. So I'm going to have negative 25 and positive 1. So again, bring my 0 down. I'm going to factor these into those two binomials. So I have x minus 25 and x plus 1. And again, because I had that coefficient there, I have to take it and divide each one of these terms by it. So I'm going to simplify if I can. I get x minus 25 over 5 would just simplify to 5. And then the 1 over 5 doesn't reduce anymore. And again, because I'm not just factoring, I'm solving, I would just leave the 1/5 over there and not swing the 5 over. So my solutions, I get x is equal to 5 and x is equal to negative 1/5. So I can write them as the set negative 1/5, 5. All right. Now we have one with 3 terms on the left and a constant on the right. So we still need to get that constant over to the left. So x cubed plus x squared minus 49x minus 49 is equal to 0. Now, none of these are like terms, so I can't combine any of them. But remember, we do have a method for factoring with 4 terms. We do grouping. So we group the first 2 terms. And remember, if this third term is negative, we put a plus in between the 2 parentheses, but we always keep that negative with the term. So I look and I say, what's my GCF of x cubed and x squared? I can take out an x squared, and then I'll have x plus 1. And then remember, I told you, if the third term is negative, you will always be factoring out a negative. So I factor out my negative 49, and then negative 49x divided by negative 49 gives me an x, and then negative 49 divided by negative 49 gives me a plus 1 is equal to 0. Now, guys, remember, with grouping, this is our goal. We want this to be the same, and then it becomes a GCF and just factors out to the front, x plus 1. And then what do we have left over? We have x squared minus 49. And those go together in their own parenthesis. Now we want to check, am I completely factored? We'll have an x plus 1, nothing factors there, up, but then I notice I have an x squared minus 49. That's a perfect square minus a perfect square. So I've got to go one more step and do my difference of squares. So that becomes x plus 7, x minus 7 is equal to 0. And so now I have my solutions. X is equal to negative 1, negative 7, and 7. So we can write it as the set, negative 7, negative 1, 7. And again, we see that there are 3 solutions because our original expression or equation had a degree of 3. Okay, now every once in a while you get one that you're like, okay, well now I can just set these equal to 0, but not quite. It's almost factored for you. You have one factor already factored out, but we can see if we can factor this. So again, I go over here, I'm trying to multiply to negative 6, combine to negative 1. I know those factors would be negative 3 and positive 2. So I'm going to bring my x plus 1 down, x minus 1, because nothing happened to that. And then I have my new factors from my trinomial. I have x minus 3 and x plus 2. Now again, I want to make sure that works. X times x is x squared, plus 2 minus 3x is negative 1x, and negative 3 times positive 2, it does give me my negative 6, so I know I factored it right. And so now that I have all of it completely factored, I can set each one of those to 0, or again, I know that my roots or my zeros are just the opposite of those numbers inside the parentheses. So I have 1, 3, and negative 2. So I can write the set negative 2, 1, and that's supposed to be a 3. 3, and then I close my bracket. And so those are my solutions. And again, I had 1, 2, 3 x's, so I have 1, 2, 3 x's. Now, the last thing that we're going to talk about today is that whenever we first talked about quadratics, we talked about the root form of a quadratic. Now, it's helpful whenever you know the roots that you can write a quadratic function from the root form and then just multiply those roots to multiply those factors to get it back into standard form. Now, in all of these examples, we're not going to have an a, but you would be told if you had an a. So remember that our root form is x minus the root and x minus the root. And then remember, we kind of knew that right here because when it was x minus 1, our root was 1. So remember, when we're putting them back into our parentheses, we're always going to change the sign. So I'm going to say I've got the equation y is equal to, and I'm going to take my x, it's positive, but in root form it'll be minus 6. And then I have my negative 1. That would be minus a negative 1 or plus 1. So then we can simplify this and find our quadratic equation. So x times x is x squared. My outer is 1x. My inner is negative 6x. And my last is negative 6. So when we combine our like terms, my quadratic function would be x squared minus 5x minus 6. And that would be the standard form quadratic of those two with those two roots. All right, let's look at our next one. So we're going to have y is equal to, and we change our signs when they go in, so x minus 9 and x plus 9. So then we're going to factor these. So y is equal to x times x is x squared. I said factor, I meant FOIL. X times x is x squared. Then we have our outer is plus 9x. Our inner is minus 9x. And then our last is negative 81. And we could see that those terms cancel each other out. So y is equal to x squared minus 81. And that would be our standard form quadratic. Okay, last example, given roots. So y is equal to, I'm going to change the sign, x minus 2, x minus 7. So y is equal to, we FOIL this back together, x squared. My outer is negative 7x. My inner is negative 2x. My last is positive 14. So y is equal to x squared minus negative x plus 14. All right, hope that helped. And if you have any questions, ask your teacher.